Hello everybody, in this video we're going to be talking about how fast a Rubik's Cube can turn. Now I don't mean in moves per second, I mean how fast are the pieces actually moving at, when you're doing a solve. So, what you saw there was me doing about 16 moves in a second, but we want to figure out how fast the pieces are actually moving. So how do we determine this? Well, we need to figure out how far one piece moves in one move. So, here's how we're going to do that. So, we'll draw a diagram of it. Alright, and this is 57 millimeters. So that's the typical, size for a cube. So we'll go with 57 millimeters. If you have a different size, you can use that. It'll still work. So we need to figure out how far the pieces are moving on each other. And the way we're going to do that is we're going to try to figure it out so we can see how far these outer pieces are turning all the way around the cube in one turn. So to do that, we need to find the diagonal of this. So how do we do that? Well, we need to start by drawing it in here. So that is the unknown there. Now, using Pythagorean theorem, we can determine that because this is a right angle on both sides. But we're going to go a little bit simpler than that. It's the 45 degrees, 90 degrees theorem. And that states that if you have a right triangle and these are 45 degrees, alright, that wasn't very good. But anyway, if they're 45 degrees like that, there's a 90 right here. This is equal, and then the hypotenuse is x root 2. So obviously these are 45 degrees because you're bisecting a right angle. So that's how we'll determine that. So to set up the equation, we will take 57 and then root 2, and then we need to figure out how far it travels around the circle a bit. Circumference equals 2 pi r, or pi diameter. So we'll go with pi diameter. So this here is the diameter right there, and then we add pi in. So that's how we'll do that. Alright. And now, that will go the entire way around, but that's 4 moves. We need to get rid of 3 of those moves. So we're going to divide it by 4, and that'll give us how far it's traveling in one move. And now, this is still in millimeters, so that's how we're going to convert it for now. Okay, so now we need to put in how many moves you did in a second. So, I did 16 in a second. And now, we have to add in how many seconds are in an hour. There are 3,600 seconds in 1 hour. This. So, that's how many are in an hour. And using this number, this is how fast a cube is going at. Alright, so, now if you have different variables, your cube size is different, your rate of moves in a second is different, here's an equation that you can use. So speed equals length root 2 times pi 900, and then this is moves in a second. So if you're wondering how we get to that, well, here's how we're going to do that. So we're going to over here. So we take the length, which will be 57, then we take root 2 pi over 4, and then this next one is moves in that I did, and then 3,600. Alright, so now we need to simplify it to get it so that it is now equal to this. Okay, so here's what we're going to do. So this part here is being multiplied, and now the 4 is over that. So we got to put the 1 like this. That way we multiply it over. Okay, so this is what we get. Okay, so over 4. Okay, now we gotta divide 4 out of that whole thing. Since it's all one, I forget what the word is, but anyway, it doesn't have like plus or minuses, you know. We only have to like take a 4 out of this. So we'll go simple, and we'll take a 4 out of that. So then S equals L root 2 pi moves, and then 900. Alright, it's a little out of order, but yeah, that's how that equation works there. Alright, so that's how you determine that. Okay, now we're going to move on to determining how fast my moves are. So, we'll go back to the equation. So, it was 57 root 2 over pi, no, times pi, divided by 4. Or actually, to make it a little bit simpler, we're going to use the equation that I came up with. So speed is the unknown, but we do know the length, which is 57 millimeters, and then we take root 2 times pi, and then the moves in a second is 16 times 900. Okay, so now that equation up there, it's in exact form. Now, we're not going to be rounding until the very end, just so that we can keep it as accurate as possible. Okay, so we're going to get rid of all these numbers here before we divide this root 2, or no, multiply root 2 in the pi. Okay, we're going to multiply these together. Okay, so, come on, focus. Okay, so we'll take 16 times 900, alright, times 57, it equals 820,800. Okay, so that is the number we'll put in. So that times root 2 times pi is our answer. Okay, so we've got our exact answer right there. Alright, so now is the time where we have to start rounding. Okay, so we're gonna go with alright, come on, focus. Come on, let's focus. Alright, actually I'll zoom out a little bit. Alright, so 2, alright, let's see, root, so that's the root of 2 times pi, 3.14 equals, alright, so that's what it equals, and now we need to multiply it by 820,800. Okay, so that is our exact answer in millimeters. So it can go 3,646,718 millimeters in an hour. Okay, so now we're going to convert it into kilometers. So I'm gonna go get the answer from a converter on the computer, so I'll be back in a minute. Okay, so if we take that number, the cube can go at 3.64, so we'll round it like that. So we're gonna round it up a little bit. 5 kilometers an hour. So, that is our answer in kilometers, but in miles, it is 2.2659. So it'll be 2.2, we're going to round it up, 7 miles per hour. Okay, so that is the speed I turn at right now. So 3.65 kilometers an hour, 2.27 miles per hour. And then we'll put the equation here. So speed equals length root 2 times pi m, or moves in a second, times 900. So that is our equation. We'll zoom out a little bit. Okay, so that is how to determine how fast you turn at a Rubik's Cube. So yeah, I hope you enjoyed this video. Hope this was interesting, and I will see you on my next video.